Welcome to lesson 0 of Vyper for beginners. In this lesson, we're going to learn how to set up our dev environment. We're going to cover our dev tooling of choice, install Foundry, set up our virtual environment, configure our project, and do a test deploy. Now, before we get started, I want to call out, you can also opt to choose Remix. Remix is an online code editor, and you can write your code and with a couple of clicks deploy and test your smart contract. And it's really nice because it gives you a user interface. But I like to use a dev tool because that's where you end up doing most of your smart contract development anyway. So I like to get started straight away in a developer framework. And the cool thing is, with the developing framework that I'm going to show you and the repo that I've set up, you'll have a UI to interact with your smart contract as well. So let's take a look at the libraries that we're going to use. We're going to install Foundry so we can get access to Anvil. Anvil is a local blockchain that we can spin up where we can do test deployments. When we install Foundry, you'll see exactly what that looks like. Ape is a Python smart contract development framework. Web3.py is used to interact with smart contracts. It connects to any blockchain, also a local blockchain like Anvil or a live blockchain network, and it interacts with a deployed smart contract. And we're using Streamlit, which is a Python library mainly used for AI, but it generates user interfaces. And we're going to use that to generate a user interface and connect it to web3.py, which connects to our smart contract. Let's take a quick look at how Ape works. So Ape picks up any smart contract code that we write and then compiles it. In simple terms, compiling means transforming our code, which is human readable syntax, to a machine code or a machine language that a blockchain understands. And then it deploys our smart contract to a blockchain. In this series, we will deploy our blockchain locally, but Ape is also perfectly capable of deploying to a live blockchain network. Web3.py is used to connect to a blockchain, and more specifically, it's also able to connect and interact with a deployed smart contract. So developers can use Python scripts to interact with anything that is deployed on a blockchain. All right, so the first thing that we're going to do is install Foundry. So if you Google install Foundry, head to the first link, and what we need to do is run this command inside our terminal. I'm gonna copy that, paste it. I've already done it, but this might take a little bit longer on your end. Once you're done, you need to run Foundry up to add Foundry to your path, so your shell knows where to find all the Foundry commands. I'm gonna go ahead and type Foundry up, and that will download and finish the installation of Foundry. Awesome. Now, if you clear your terminal and type in Anvil, you should see something like this. Right now, I'm basically running a local blockchain called Anvil with a bunch of available accounts that are pre-funded, private keys to access the accounts, a chain ID, and a URL to connect to this blockchain. First step cleared. I'm going to end the process by typing Control-C on my keyboard, clear the terminal, and I'm right now in an empty folder. If you want to create an empty folder locally, you can do make dir and then with a folder name, and that will generate an empty folder. But the first thing that I'm going to do is git clone, and then I'm going to head over to the repo. I'll have a link in the description, copy the repo of PyRemix and paste it. This will download the repo locally for us ready to use. We'll go through this repo in a bit, but first navigate to PyRemix. You type ls, you'll see all the folders that are available. Cool. The next thing that we're going to do is run python 3-m venv./myv. Hit enter. This will generate a virtual environment. If I type ls again, I can see the myv folder. Now I need to activate the virtual environment by typing source./myv bin activate. Now over here you can see that my virtual environment is activated. If you have a different terminal, it might show up slightly different. Now we can install all our dependencies. You do that by going pip install -r requirements.txt. Hit enter, and this will install all the dependencies. While this is busy, I'll show you what's being installed. If you head over to requirements.txt, let me make this slide bigger, then over here you can see all the libraries that are being installed right now. You could also do this manually by doing pip install and then typing out each individual name, but with the requirements.txt, it just grabs it all and installs it for us. Awesome, this is done. If you want to see how to set up this environment manually, I'll leave a link to a video that I've done before on how to set up your Ape environment, but we will be using the pre-configured setup inside this repo. Now, if you don't know what a virtual environment is, by the way, it's like a small little room that we can create inside our computer where we can install a bunch of stuff without our computer being affected. Let me show you. Right now, we have installed all our dependencies inside our virtual environment. If I type in ape, you can see all the command line options that I have. If I type right now deactivate, and then I type ape --help, you see nothing happens. As a matter of fact, it says command ape not found. And that's because ape is installed inside our virtual environment, not globally on our computer, which is pretty cool, so we keep our computer clean. I'm gonna go ahead and see if I'm in the right folder, and I see the myv folder, so that's great. Next, I'm gonna activate myv bin activate again. Over here, I can see my virtual environment is activated. And now if I run ape --help, I can see ape. I have access to all the ape commands, which means I'm back in my virtual environment. Okay, now over here I have the repo, but I can also open it inside of my code editor. Let me go ahead and do that by typing code dash code space and then a dot, and this will open the code editor inside the current directory. If you do not have that option, what you can do is manually open your Visual Studio Code, press Command Shift P, and then search for install code. And if you click this, it will install the code command for your shell, and then you'll be able to run that command as well. Inside, I basically have 3 folders. We already know the myv, which is my virtual environment folder. Next, you see the PyRemix and ape. In practice, you won't be touching the PyRemix much, but let's take a look at what's inside there. We have a create ABI file, a create Streamlit, a create Web3, and a run setup. The create ABI script grabs the ABI, the application binary interface, from our ape folder. Inside an ABI, all the functions and the inputs that are necessary for the smart contract are documented. This ABI is used for our web3.py script to create functions. If we click on create web3.py, over here you can see a bunch of stuff happening. We set our environment variables, and we'll go over them in a bit. And what we do is we read our ABI, and for each function, we write out Python functions to interact with our smart contract that we have deployed. Finally, in the create Streamlit script, we generate a UI to interact with our web3.py script. Now, this is just meant as a walkthrough. Like I said, we won't be touching the PyRemix. We'll be primarily working in the ape folder. Before we do that, let's take a look at our environment variables. Over here, I have an example of a .env. .envs are used to set and manage environment variables. A .env usually has sensitive information that we do not want to push towards our GitHub repo. So inside our git ignore, I've included to ignore the .env and env files to be pushed to our GitHub repo. I wouldn't worry too much about this repo because we'll be doing local development, but this is good to bear in mind. Let's generate a new file called .env. We can go ahead and copy everything that's in here and paste it. Now, there are a couple of important things. First of all, make sure there's no space behind each value. Second, we will need to set our private key inside here, and I'm going to use an Anvil private key. So even though I'm showing it, which is completely fine, never ever show your private key on screen. An Anvil private key is local and it doesn't have real funds, so it's fine. I can open up my terminal, type Anvil, and this will have a local Anvil running. I can scroll up and grab the first private key, paste it here, save it. Now over here you see a couple of values preset. The chain ID is most likely going to be the same, but it's good to check it. So this is the chain ID of Anvil. I'm going to scroll up, scroll down, and over here I can see 311.31337, so that's good. The same with the URL, the connection point for Anvil. I'm going to scroll down, and over here I can see that it's exactly the same. Double check if yours is the same as well. Finally, the account address, if I scroll up, it should be the same account for this private key over here, and I copied the first private key, so I need to copy the first wallet address and paste it here as well. You might see a contract address here, and you can leave it blank. You can leave it like this because our script will override it with the contract that we will deploy at that given time. All right, I'm going to close my .env on my example.env, head over to ape and look at a bunch of contracts that I've got preset over here. These are contracts that we will test deploy. But before we can do that, we need to set up our ape account. I'm going to open up my terminal, create a new terminal by clicking on the plus, and then I'm going to run the following command. Ape account import, and I'm going to call it Anvil 0. Whoops, that needs to be ape accounts with an S, import Anvil 0. Now this throws an error because I've already done it, but in this setup, make sure you name your ape account Anvil 0. Just to show you how the process works, I'm going to use another name, ape accounts import Anvil 1. Now I need to enter a private key. I'm going to head over to my terminal where Anvil is running. I'm going to scroll down, and you can pick private keys. Make sure to pick the same private key you've set in your .env. That would be the first one. So go ahead and pick the first one, copy it, go to Python, paste it. You won't actually see anything, and that's because it's shielded. Hit enter, set a password. I like to set an easy password because it's for local development, and then repeat for confirmation. Boom, a new account has been set up. Now when we deploy, we don't need to pass our private keys manually every time. You might ask yourself, why did we set the private keys in the .env? Well, that's for our web3.py script to use that private key, which is the same one that we use to deploy our smart contract. If this sounds confusing, don't worry, you'll see it in practice in a bit. I'm going to go ahead and clear our terminal, open my sidebar, close my terminal, and then we're going to go to the folder scripts. Again, you don't actually need to touch any of this except for the deploy_anvil.py. If I scroll down over here on line 37, you see Anvil 0. So if you just created an account with the name Anvil 0, you're good. If you changed it to another name, you need to pass here the name of the account that you chose, because on this line you can see we're loading our account so that we can deploy our smart contract. Now I won't go through the code of the deploy script as it's quite extensive. In a separate video that I will link below, it will show you exactly how to set up your ape environment and write different deploy scripts from basic to more advanced. I'm going to go ahead and close this file, head over here. Over here I have a bunch of smart contracts that we can pick from and deploy. I'm going to go ahead and pick arrays. If you don't know what arrays are and you're still confused, Don't worry too much. What I want to show you today is how to use the dev environment if you choose this one. I'm going to open my terminal, navigate to the ape folder, and make sure you're in the ape folder. So cd ape. Next, I'm going to run the following command: ape run scripts deploy anvil.py -- network, and then http /localhost, and then port 8545. Now you might think, where am I getting this from? This is the URL our Anvil node is running on. So you can also write out this, so http and then this URL, but localhost should work just fine. I'm gonna go ahead and press enter. Now you can pick a contract. So this script checks how many contracts there are in this contracts folder, and then you can pick which contract you want to compile and deploy. So in this case, we want to compile arrays, which is the third. Then I want to sign my account. Yes. Now you need to pass the password that you use to create your ape account, and you can choose to leave your account unlocked if you have multiple deployments, which we don't, but that's fine. And now you can see we're running into error, which is great. So we can tackle this together. If I go to my .env, you can see over here that the script actually made a mistake. And I want to show this to you so you know how to debug this. So in this case, the contract address got added, but it got added to the same line as the private key. So I'm going to go ahead and delete this. Save it. We'll stop this by pressing Ctrl+C, and then with the up arrow, I can rerun the previous command, run it, pick arrays again, sign the contract, unlock my account, yes. And over here now you can see it got added correctly, and here is the UI. Now with one command in our CLI, we've deployed our contract, we've compiled, deployed our contract locally, and have created a UI for it. So over here, I can start interacting with it. So this is an array is a list, and I want to retrieve the value of the first position in programming your count at 0. And so if I set the value here to 5, you can see that a transaction actually happened. If I execute to retrieve the first slot again, you can see 5 over here. So this is pretty cool, and it's pretty fast. So we didn't need to deploy it on a test net. We didn't actually need to use Remix. We developed our smart contract inside our smart contract framework, and we can immediately interact with it. Maybe an easier interaction I can show you is, here I have a function to add count, but this will add one number to the variable count. I will execute add count, and if I scroll down over here, I can see it's 2. And then if I execute the function again and get the value for user count, it turned into 3. Let's take a look at a more simple contract in case you're a little bit overwhelmed. And here what I'll do is I'll remove all the arrays. So we'll remove this, and then we will remove all these functions, and we'll go ahead and deploy this super simple smart contract. So I'm gonna stop by Ctrl+C. I will stop running my Streamlit app, press the up arrow inside my terminal to rerun the command. In this case, I want to compile and deploy my simple contract, which is 4, sign the transaction, unlock my account, and then it spins it up. Over here we can see our local UI. So if we get the value for our variable user count, it's 0 at the moment. If we add 1 to our variable, we've done a transaction. Click again, we see 1. Add 1 again a transaction. Now we can see 2, and we can keep going like this. And so we didn't have to write any code to interact with our smart contract. We didn't need to write up the web3.py file. If you want to know what it looks like, you head over to your code editor, open your sidebar, and if you see here, 2 files are generated based on the command line instruction, which is the web3.py script, and we can take a look at what happened. This script basically connects to our local provider. It uses the contract address. It uses the ABI, which has, as I mentioned before, all our functions, the necessary inputs, the type of functions for our smart contract. So the web3.py script knows how to interact with it. It makes a connection to our contract using our contract address and the ABI. It grabs our wallet address and our private key so it can interact with the smart contract, because every time we make a transaction, remember, it actually needs to be signed by a wallet address. And so over here, you can see how the transaction is built. Again, if you're interested in that, I'll leave a link in the description down below that goes through how to set up your ape environment and a web3.py script. But this is basically automated for you, so you can go ahead and focus on writing Vyper, running the command, and then having a UI to interact with that smart contract. Now again, you don't have to set this up. You can use something like Remix and then code along directly in Remix and utilize Remix to deploy the Vyper smart contract. And you can also do the exercises that you can find inside the GitHub repo over here inside Remix. So you can copy these exercises and do them in Remix if you want. That's it. We've learned how to set up our local environment utilizing Python scripts and deploy it local on a locally running blockchain, Anvil. We are all ready to dive into Vyper, learn how to write up smart contracts, and deploy and interact with them. I'll see you in the next lesson where we will start with variables and constructors. Now go and code some Python.